Hi, everybody. This is Gigi Drent from Kauai Community College. Today, we will be talking about exponents. All right, so let's get started. All right, so exponents. What's an exponent? Okay, so suppose you have a to the nth power. Like, what is that? That's right there. The n is the exponent, and the a is the base. Okay, so what does that mean? That means you are going to multiply repeatedly the base n copies. Okay, so for example, if you have 2 to the 5th power, you have 2 to the 5th power, that really means 2 times 2 times 2 times 2 and another 2. There are 5 copies, okay, 5 copies of 2 multiplied to each other. Okay, and so that, what is exponent? Exponent is repeated multiplication. And then we have a base and you have an exponent. So be sure when we are working with exponents to think, what is my base and what's the exponent that goes on top of that, okay? All right, so what we have learned in number bases, like our number system of base 10, that really goes with exponents. Okay, so for example, 10 to the 1st power is just one copy of 10, and that's just 10, right? And then 10 to the 2nd power is 10 multiplied to 10. You have 2 copies, okay? And 10 multiplied to 10 is 100, okay? Similarly, 10 to the 3rd power would be 10 multiplied to 10, multiplied to 10 again. We have 3 copies of 10, and that will make 1,000. So if you think about how we write our number, let's say, for example, 5,364, it would be 5,000, right? 5 groups of 1,000 place value, 3 groups of 100, 6 groups of 10, and 4 singles. Yeah. So now this right here, as we can see, is 10 to the 3rd power. And then the 100 is 10 to the 2nd power. And the 10 right here is 10 to the 1st power. And if we follow this right here is the ones, but what do you think that is in terms of 10 power of 10? Well, if we follow this pattern, 3, 2, 1, this must be 10 to the 0 power. And we're going to explore that concept in just a little bit, why 10 to the 0 power is 1. Okay. All right. So let's just think about teaching sequence. How does this go? Okay. So first, you'll start out with something like this that said 10 to the 3rd times 10 to the 5th, right? So now always go back to the definition. Try not to give students rules. So then 10 to the 3rd power, always go with the definition, is 10 times 10 times 10, and that give you 3 copies of 10, right? And then we're multiplying that by 10 to the 5th power, and that is an additional 5 copies of 10. So 5 copies of 10, right? So if you think about it, that right there visually shows you 8 copies of 10. Therefore, we would write it by definition as 10 to the 8th power, because the exponent means how many copies there are, and the base is a number that we multiply repeatedly, and that is 10, right? So, and then so you would jump from numbers to a variable base, like x to the 7 times x to the 6. Now, if you have done so many of example 1, then we would go ahead and see the pattern. And most people would say, oh, hey, don't you just add the exponents? Well, of course you do, but let's explain why, right? So x to the 7 is how many copies? 7 copies, right? So 1, 2, 3, 4, 5, 6, 7. And there you go. So 7 copies of x multiplied by, and I'm going to use this dot right here so I don't confuse my multiplication with my x's. How many more copies of x? 6 more copies of x. So therefore it's 1, 2, 3, 4, 5, 6. And altogether, as we can visually see it with our own eyes, that it is 13 copies. And when you have 13 copies of x, we say x is the base and 13 is the exponent, right? So then we move on to say this right here, have 3 to the second multiply 3 to the m power. So now you do a little bit of a variable, but variable in the exponent. Okay, so that's like a step up of example 2, right? So 3 is my base to the second power. So I have 2 copies, right? Multiplied by 3 to the m power. So I have m copies. And the base would be 3. So it would be 3 times 3 dot, 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 multiplied by 3. And how many copies of those? M copies. So let's go back to see if I had 3 copies and I have 5 more, that would make 8 copies. If I have 7 copies of x, 6 more copies of x, I have 13 copies of x. Now, if I have 2 copies of x and m copies more of x, I would have 3 as my base, and my exponent would be 2 and m more, 3, 2 plus m as my exponent, right? Okay, so how does this work? A to the n power times a to the m power. Okay, so we're coming towards a property here with exponents, right? So to visualize it or to prove it, we would say a times a times a times a. And how many copies here? You have n copies, right? Because n is the exponent. And then here we have a is the base, so it would be a times a times a times a times a. How many copies here? M copies of a. Now, all together, if we visualize it, how many copies of a do you have? And what is the base? The base is a, and I have n plus m copies of a. Therefore, we just show our first rule of exponent. And people usually say when you multiply exponential expressions with the same base, that's the a, we keep the base the same, which is a, because that's how many copies there are, and we add the exponents. Okay, so that's rule number 1. So what happened then when we have division, right? For example, before we do division, let's think about what these things mean. 3 divided by 3, what do you say? That is 1, yeah? 7 divided by 7 is 1, right? So a divided by a, which is an amount divided by itself, a number divided by itself is 1. Yeah? Well, what's the difference between those and the next one? There isn't any difference. A to the n is a number. A to the n is a number, the same number. So a number divided by itself is still 1, right? Okay, that's logical. Yeah? Okay, so we're going to use this concept when we investigate some division of exponential expressions. So let's say you have 2 to the 10 power divided by 2 to the 4th power. Well, by definition, on the numerator, you have 10 copies of 2, and then on the denominator, you have 4 copies of 2. So it will look like that, right? Now, what are we going to do? We're going to use this concept right here, yeah? Here we have 2 divided by 2, that is 1. 2 divided by 2, that is 1. 2 divided by 2, that is 1. 2 divided by 2, that is also 1. So what do we have left? 1 copy of 2, 2 copies, 3, 4, 5, 6. 6 copies of 2 being multiplied repeatedly. That is a definition of exponent with base 2, and 6 is the exponent. Okay, so you will pay attention to how the 6 comes about. Why are there 6 left? Because I have been able to divide out 1, 2, 3, 4. 4 copies of 2. Because 2 divided by 2 is 1. And then 1 multiplied by anything is itself. So really, it's just 2 to the 6th power. Okay, so based on that, we would say this right here is what? Okay, always, whenever you don't remember the rule, go back to the definition. You can always figure out the rules, right? So on the numerator, you have a to the 5th power, which would be 5 copies of a multiplied repeatedly. And then on the denominator, you have 2 copies of a, right? And then again, a divided by a is 1. A divided by a is 1. So I have 1 copy, 2 copies, 3 copies of a being repeatedly multiplied. So then we will have an exponential expression, because that's the definition of what an exponent is. The base is a, and the exponent is 3. So again, focus on how did we get a to the 3rd power. And that leads us to rule number 2. When you have a division problem with the same base, okay, with the same base, we keep the base the same, and we subtract the exponents. Makes sense, yeah? Okay, now here, I'm going to go ahead and think about this right here. Why a to the 0 power is 1. Okay, so I'm gonna go ahead and make a little adjustments here. So an addition to the slide. Okay, so you have a to the n divided by a to the n is 1, right? Now, another way of thinking of this, now that we have just learned about property of exponents, if I have a to the n divided by a to the n, this property said that I can keep the base the same and subtract the exponent, n minus n. And n minus n we know is 0. So a to the n power divided by a to the n power is also known as a to the 0 power. Therefore, a to the 0 power must be 1, right? So what does that mean? Anything, a is for anything to the 0 power is 1. All right. Next, we will look at this property here, which said if you have a to the n power, raise it to the m power, then we would multiply the exponents and keep the base the same. Well, let's see how that developed out in our journey here. Okay, so if you have 2 to the 3rd power, and then all that raised to the 4th power. So if you think about definition of exponent, this to the 4th power here is the exponent, and this right here is my base, right? So that's my exponent, and this right here is my base. So I have 4 copies of 2 to the 3rd power, right? How did I get that? 4 is the exponent, let's see. 4 is the exponent, and then the exponent goes on top of the base. So my base really is 2 to the 3rd power. That's the base, right? Okay. Now, property number 1 said when I have exponential expressions with the same base, in this case now, in this step, my base is 2, okay? And property number 1 said when I'm multiplying them here, with the same base, what am I doing with the exponents? I would add them, right? So 3 plus 3 plus 3 plus 3. And that equals to 2 is my base, okay? And what does this define? Repeated addition is multiplication. 4 copies of 3. That means 3 times 4. And that is 2 to the 12th power. Okay? But let's think about the process of how we get that. Repeated addition is multiplication. Okay, same concept here. Let's do that one more time. And this would be your teaching sequence again, right? Try to abstractly squeeze in the variables. So this would be 3, right now, 3 is the exponent and x squared is the base. So I have 3 copies of x squared. And so that equals, keep the base the same. Rule number 1 said keep the base the same and add the exponent. 2 plus 2 plus 2. And guess what? Repeated addition is multiplication. So the base is still x. The exponent is 2 times 3. And that is x to the 6th power. Okay. Now, same concept will apply. We have x to the 3rd power multiplied to x to the 3rd power. In this case, how many copies do we have? We have b copies, right? Now this is going to equal to, the base is x, the exponent is 3 plus 3 plus 3, and so on. And we would repeatedly add that b number of times, right? And repeated addition is multiplication. So you have x to the 3 times b, which is x to the 3b. Okay, now I think that's convincing enough, right? How do we get, when we have an exponent raised to an exponent? According to what we have seen here in our pattern, we would say that is the same as x is my base, And what am I doing? Multiply the exponent. So that would be n times m. Okay, and the examples are up there for us to see. Yeah, because what we'll end up doing is add the exponent repeatedly, which defines multiplication. So that is how rule number 3 works. Okay, now here, a to the third power times b to the third power, that is going to equal to a times a times a, multiplied by b to the third power. By definition, b times b times b. Okay, now what do we know about multiplication in terms of property of the operation? When we multiply, we have the any order property applies here, right? Meaning I can switch the order when I multiply. 2 times 3 is still the same as 3 times 2. So I can switch the order. And if I can switch the order, what I could do in this case is take A and B to be right next to each other. So it will be A times B, another A times B, and another A times B. Okay, so what did I just do? I switched the order and squeezed the B in next to each one of these, right? And so I have this. Now, what does this say? I have now 3 copies of AB, A times B, right? If I have 3 copies of AB being multiplied to each other, then AB, by the definition of exponent, AB is my base, and my exponent is 3 because I have 3 copies of AB. Okay, so this gives us the fourth rule of exponent, and that is a to the n times b to the n is the same as a times b altogether to the n power. Okay. Now let's practice these rules. Just don't make up your own, right? Okay, so first you would look at this right here and you would say, oh, that's division. So I'm gonna go ahead and subtract the exponent. Well, if you were to say that, what you are ignoring is the base. Okay, so always think when you're dealing with exponent, what's my exponent and what's my base? So here, look at this. The bases are not the same, right? So when the property of division said, rule number 2 said, if you were dividing 2 exponential expressions with the same base, then you can subtract the exponents. Not in this case though, right? So in this case, what we have here is 6 on a numerator. So we really should be thinking here, let's deal with the denominator first. 3 times 3 times 3 times another 3, 4 copies of 3. Now, when we have no idea of how to apply the rules, we should always go back to the definition of what things mean, right? So 6 to the 5th power. Well, I know that 6 is 2 times 3 to the 5th power. Okay, now based on the property that we had just seen there, that is going to equal to this right here is going to equal to 2 to the 5th power multiplied by 3 to the 5th power, right? That's the a times b to the n power is the same as a to the n times b to the n, right? So I can split them up that way. And now by definition, I have 2 to the 5th power. I'm going to leave that there because I'm really interested in dividing out the 3 on the denominator here. So 3 to the 5th power on the numerator is 3 times 3 times 3 times 3 and another 3. And on the denominator, how many copies do I have? 4 copies here. So I can divide those out to get 1. And so really, I have 2 to the 5th power times 3. That is what is left, right? Or after you think about this here, you can just say, oh, hey, that is 2 to the 5th power times 3 to the 5th power divided by 3 to the 4th power. When I divide things with the same base, the 2 to the 5th power is going to stay the same because there's nothing for you to divide out. But then here, when I divide out things with the same base, I can keep the base the same, which is 3, and subtract the exponent. And when I subtract the exponent, 5 minus 4 is 1. So I would get the same answer as previously, but using the property of exponent rather than writing out using the definition, right? So whichever way you are headed, make sure you do understand these properties and just don't make up your own. All right, so this looks very abstract, right? But again, what are we paying attention to? What is my base and what's the exponent that goes on top of that base? Okay, so slowly we will apply the property of exponents. So here you have a multiplication problem, both raised to the 3rd power. So really that becomes x to the 4th power multiplied by x to the 3rd power times y to the 3rd power. That's rule number 4, right? And then on the denominator, I have x to the 3rd power times y squared. Okay, so property number 1 tells me that I can combine these because those are being multiplied with the same base. So that is the same as x to the 7th power times y to the 3rd divided by x to the 3rd times y squared. And guess what? Each one of these variables is a division problem, right? So here's a division problem. Here's another division problem. And when I divide exponential expressions with the same base, I keep the base the same and I subtract the exponent. So that gives me 4 as an exponent and the base is x, multiplied by here, dividing exponential expressions with the same base. I'm going to keep the base the same, subtract the exponent, and that gave me 3 minus 2 is 1, but I really don't need to write a 1. That's just one copy of y, which is y. All right, that's that. Okay, now pause the video and repeat the problem on your paper. Make sure you really digest that information. Okay, we're going to move on to something a little bit more complicated than that. Okay, so when you look at this right here, you would say, oh my gosh, none of these bases are the same. But what we should see would be to say, oh, hey, there's 5 inside the 15. There's 2 inside the 8 and the 12, and there's 3. So wait, let's break these down into their smaller factors, right? And this would be to write the bases as their prime factors, which is smaller numbers, okay? So 6, for example, 6 is 2 times 3, right? So 6 is 2 times 3. So that would be the same as, okay, I'm going to go ahead and rewrite this. 6 to the 4th power is the same as 2 times 3 raised to the 4th power. Okay, and then the 12. What is 12? Well, have you seen the factors tree? It goes like this. 12 is 3 times 4. 4 is 2 times 2. So here I have 2 times 2 times 3 equals 12. So to write that, I would say that is the same as 3 multiplied by 2 squared. Okay, so this right here, 12 to the 3rd power, I can write that as 3 times 2 squared raised to the 3rd power multiplied by 15. And you got it. 15 is 3 times 5 to the 2nd power 9 is 3 times 3, which we would write as 3 squared, and then raise to the second power. Okay, then 8. How do you see 8? 8 is 4 times 2, and 4 is 2 times 2. So I have 3 copies of 2, which would be 2 to the third power, and then that is being raised to the second power, multiplied by 5. Okay, so now we're going to go ahead and, we're going to go ahead and not end the problem, but go ahead and try to finish this problem here. 2 times 3 to the fourth power, property number 4 said it's going to be to the fourth power times 3 to the fourth power. And then 3 times 2 squared to the third power is going to be 3 to the third power multiplied by 2 to the second power to the third power. That would be like this. Times now 3 to the second, 5 to the second. And then in the denominator, you have here 2 to the second power. That's property number 3. That said, when you have an exponential expression raised to another exponent, you would multiply the exponent. So that would now be 3 to the fourth power. And then 2 to the third raised to the second power is going to be, keep the base the same, multiply the exponent. So that gives you 6 times 5. And guess what? You kind of see this right here, right? That's another one of those properties. So 2 to the second to the third power right there is going to be 2 to the sixth power. So what I'm going to do is I'm going to erase this part that I had here, and I can think 2 to the second to the third power is now 2 to the sixth. Okay, now on the numerator, you will see that there are exponential expressions with the same base being multiplied to each other. So we are going to go ahead and simplify those, right? So first, I have 2 to the fourth power multiplied to 2 to the sixth power. Keep the base the same, add the exponents. Okay, and then for 3 to the fourth power times 3 to the third power times 3 squared. Keep the base the same, add the exponents. 3 plus 4 is 7, plus 2 more is 9. And then here I have 5 squared. Here is multiplication. Any order property applies. So to make it nice, I'm going to write 2 to the 6 in the front, 3 to the fourth here, and then 5. Now, each one of these is division of exponent with the same base. So I am going to keep the base the same, subtract the exponents. I have 4 multiplied by this right here, division problem with the same base. Keep the base the same, subtract the exponents. I have 5. And here, division with the same base. Keep the base the same, subtract the exponent. This is 1 right here. So 2 minus 1 is 1, which I really don't need to write. So that is just it. And that is how you deal with exponents. So always think, what is my exponent? And what is my base? Okay, that is it for today.